Welcome to Math 154 videos. This video is going to go over the derivative as a function, and we're going to consider, given the graph of a function f, how can we sketch f prime. So here's our function f. It's graphed right in front of you, and so we're going to try and sketch f prime by using these three steps that I've outlined here. So the first step is, where does f have a horizontal tangent? This means f prime, the derivative, is going to be equal to 0. Well, looking at this graph of f, we can find one point right here where when we draw the tangent line, it's going to be horizontal. So we're going to call that point A. And let's start our graph of f prime over here. So first we're going to label that point A. So here's f prime. We're going to label that point A. And we know that at A, f prime is 0. So we're going to plot a point there at A, 0. Alright, now, where does f have discontinuities or corners? So there's one corner in f, and it's right here. So we're going to label that point B. And that's going to be a place where the derivative does not exist. So we're going to sketch that, and I'm just going to draw a line here so we have sort of an asymptote here. And that's B. So that's a place where the derivative does not exist. So now we've got to find out, where is f prime positive or negative. So this is step 3. So we want to find between B and A, and to the left of B and to the right of A, where is the derivative positive or negative? So down here I'm going to make this little f prime, and we're going to see where the derivative is positive or negative. So here's B and here's A. So to the left of B, if we draw a representative tangent line at a certain point, we're going to see that that line is going to have a positive slope. So that means to the left of B, the derivative is positive. Alright, then between B and A, if we draw a little representative tangent line, we're going to see that that actually has a negative slope. So between B and A, we have a negative derivative. Then to the right of A, drawing a little representative tangent line, we're going to see that that has a positive slope. So to the right of A, the derivative is positive. So you have positive, negative, positive. Alright, going over to our graph of f prime. To the left of B, we said the derivative was positive, and if we look at that a little bit more closely, as we get closer to B, that tangent line actually gets steeper. So you see this first one here and the second one where I'm drawing the arrows. The second line is a little bit steeper than the first. So as we get closer to B, we're going to be all positive values of our derivative, but getting closer to B, those values are getting bigger. So that's going to go closer and closer to infinity. Then, to the right of B, we're going to have, starting out with very steep tangent lines with a steep slope in the negative direction. So that's going to be way down here, and they're going to get less steep as we get closer to A, and then we're going to hit 0 at A, where our tangent line is horizontal. Then to the right of A, the derivative is positive again, so we're going to be above the x-axis on our graph. That indicates a positive value for the derivative. So that's going to be up here. And there's our graph of f prime. So remember, f prime is graphing the value for the derivative. Okay, so the points where our horizontal tangent are at A, those are going to be 0. And then we got to see where the derivative is positive or negative. If the derivative is positive, its graph is going to be above the axis at the x-axis at those points. If the derivative is negative, then its graph is going to be below the x-axis at those points. So there is our function f and its derivative f prime. So here's our second example, and we have another graph of a function f, and we're going to go through the same 3 steps to figure out our graph of f prime. So our first step, where does f have a horizontal tangent? There's going to be 2 places on this graph where we have a horizontal tangent, one right there and one right there. So we'll label those points our point A and B. So we have 2 points A and B, 2 x values, x equals A and x equals B, where we have a horizontal tangent, which means our derivative is 0. So we're going to go ahead and sketch our derivative graph. This is f prime, and we're going to graph those points. A was right here, and B was right here. And at both of those points, our derivative has a value of 0. So those are going to be points on our graph. Where does the function f have discontinuities or corners? That's step 2. So looking at this graph of f, can you see any places where there's a discontinuity or a corner? No, there's none. So step 2 we don't really have to worry about because there are none. So we'll move right on to step 3. Where is the derivative positive or negative? So we'll have this little chart for f prime, and we're going to have A, we're going to have B. Now to the left of A, is the derivative positive or negative? Let's see, maybe we can pick some random point and draw a tangent line. That's going to have a positive slope. Pick another one here that's going to have a positive slope as well. So those are going to be positive. Then between A and B, we're going to see if we draw a representative tangent line, that's going to have a negative slope. So between A and B, our derivative is negative, and then corresponding to the right, after B, we're going to get a positive slope again, so our derivative is positive. So between A and B, that's probably going to be the easiest part because we know it's negative, and it's going to start out close to 0 at A, and we know the derivative is negative, so it's on the bottom, below the x-axis, and it's going to get steeper and then get less steep as we're approaching B and come back to 0. So that's going to look something like this. Then to the left of A, we have a positive derivative, and it's going to be getting a little bit less steep as we get towards A, and it's going to be steeper away from A. So less steep towards A is going to indicate a value close to 0. So very close to 0. And then as we get away from A, it's a little bit steeper. And then the same thing happens to the right of B. So we're going to start positive derivative values to the right of B, and they're going to get a little bit larger because we get a steeper slope over here. Steeper slope as we're getting farther away from B. So there's your graph of f prime.